In this video, let us have a look at questions from more concept. So we are going to answer questions from various years. And the first question that we are answering is this one. And the question reads, calcium oxide is produced by heating limestone following the equation below. As you can see, this is the equation that we have. Determine the relative formula mass of calcium carbonate. So that is the first question that we are doing. Now, to determine the relative formula mass, you just add the relative atomic mass of all the atoms that are in calcium carbonate. In this case, you take note of also how many are they. So here we have 3 oxygen, and oxygen, you know that the atomic mass is 16. This gives us a 48. Then for carbon is 1. We just have 1 carbon, but each carbon is a 12, so equal to 12. Then calcium, we just have 1 multiplied by 40, each is 40. So we add, and this is going to give us 100. And that is the answer for this, or that is the answer to this question. Then question B, determine the mass of calcium oxide produced if 400 grams of calcium carbonate is decomposed fully. And I guess there's no one with a problem on this particular part, how to find the relative formula mass. It's a ratio, so there are no units that are involved. So how do we determine, for a B question, how do we determine the mass of calcium oxide produced? So in this case, we have to, okay, the equation is already there. And of course, if we are to check, it is balanced, calcium 1, calcium 1. Oxygen, we have 3, oxygen 1 and 2, 3. So it is already balanced. So what we are going to do here, since we are told of calcium oxide and calcium carbonate, we are going to form a ratio of calcium carbonate to calcium oxide. We find their relative formula mass and treat them as the mass. So here we are going to have the relative formula mass of calcium carbonate is 100, 100, and of course gram. Then for calcium oxide, calcium is 40, 16, that is oxygen, so it gives us 56 gram. So which means if 100 gram of calcium carbonate is decomposed fully, it produces 56 gram of calcium oxide. But what about if you decompose 400 gram? So here, that is why we're going to have 100 gram produces what? 56 gram. What about 400 gram of calcium carbonate? What would be calcium oxide? So you cross multiply here, and you're going to have X is equals to 400 multiplied by 56. Okay, remember here we are going to find the mass in grams. Okay, so 56 divide 100. So if you divide this, you're going to cancel. We can cancel out these zeros. We can cancel out those zeros. Then we have X is equals to 56 multiplied by 4 is 224 grams. Be able to confirm these numbers. Okay, as you go through, make sure that you also calculate. So that is how you find the mass. And here we've used mass to mass. So a different method that you can use. You can use mass to mass, more to mass, or more to more. But these other methods are not direct, because if you use mass more to more, you have to find the number of moles of this part, okay, of which using this, then you are going to use the coefficient. Then afterward, you have to use the formula to calculate the mass. So that procedure is all long, but you need to look at the shortest way that you can work it out. Okay, so that is the 2 marks. Then question C, give one natural and artificial use of the gas produced in the reaction above. Now, if I look at the reaction here, the gas that is produced is carbon dioxide. So in other words, what is the artificial use of carbon dioxide and what is the natural use of carbon dioxide? So for natural use, we are looking at the process that use carbon dioxide in nature, and we can say used by plants, okay, during photosynthesis. You know that carbon dioxide is a raw material needed for plants to manufacture. Therefore, that is the process of photosynthesis. So used by plants during photosynthesis. Then what about artificial? So artificial, we can look at man-made processes and all that. So it is used in baking. So baking uses carbon dioxide. Then also you can talk of used in what? Fire extinguishers. Then you can talk of also used to make carbonated drinks. So there are quite a number of use of carbon dioxide. You should be able to bring out so many uses. Otherwise, we end here in terms of this question. We've answered it fully, and that is the 4 marks. Then up to the next question. Elena reacted a certain mass of magnesium. With 150 centimeter or cubic centimeter of dilute hydrochloric acid. 240 cubic centimeter of hydrogen gas was evolved, which means was produced at room temperature and pressure. So you need to take note of the condition RTP. And what should come to your mind is the volume, the molar gas volume at RTP, which is 24 in decimeter cubic per mole. So if it's in decimeter, it's 24. But if it's in centimeter, others will prefer using it in centimeter or cubic centimeter, which is 24,000. Okay, 24,000 cubic centimeter. Construct the balanced chemical equation for the reaction. So what is reaction here? Magnesium. So magnesium, which is a solid, react with hydrochloric acid, HCl. And I normally emphasize that you know all the acids. That is 4 strong acids and their formula. That is nitric acid, hydrochloric acid, sulfuric acid, and phosphoric acid, especially the 3. Okay, that is the nitric, hydrochloric, and the sulfuric. So here what is going to form is the magnesium chloride, which is the aqueous, plus this is acid and a metal, and you need to know that general reaction. What is produced is a gas. Now they've told us a balance equation. Is this balance? We check the atoms here. We have magnesium, 1 magnesium. We have hydrogen. We have 2 hydrogens there. So we can put a 2 in front, 2 hydrogens. Then chlorine, it becomes 2 right here. And also we have 2 chlorine here. So this is the balanced equation that we can write here. Okay. Then calculate, that is for B, calculate 1, the number of moles of hydrogen in 240 cubic centimeter of the gas. So to calculate number of moles, you need to know these 4 formulas. Number of moles is equals to given mass over molar mass. So this is when you are given mass. Are we given mass? No. The other one is number of moles is equals to number of particles divide the Avogadro's constant. We have number of particles and Avogadro's constant? No. The other one is number of moles is equals to concentration multiplied by volume. Volume in decimeter cubic and concentration in mole per decimeter cubic. Do we have that? No. The other one is number of moles is equals to given volume over molar gas volume. Do we have that? We have the given volume. And we've been told the condition is at RTP, so which means the molar gas volume is 24 or 24,000, like I've said earlier on. So whichever you use is going to give you the answer. So molar gas volume, given volume divide Vm equal to, I'm going to use the one that is in centimeter, cubic centimeter. So which means down I'm going to use 24,000 cubic centimeter per mole. So that this and that cancels. Then this and that cancels. So we have 24 divide 2,400. And this one is giving me 0.01 more. So please be able to confirm. So that is what it has given me. Then the mass of, that is on 2, the mass of magnesium used in the experiment to produce 240 of hydrogen at room temperature. So now how are we going to find the mass of magnesium? Remember the formulas that we have. For us to find the mass, we need this one. And now for us to use this one, we need we need to find the number of moles. Molar mass of magnesium we can find is 24 on the periodic table. So what we need is the number of moles of magnesium. Now, which way can we find the number of moles of magnesium? Because we do not have any information for magnesium. Okay, so which way are we going to use? So for magnesium, let us check. Elena reacted a mass of magnesium with a certain mass of magnesium with 150 dilute hydrochloric acid. So we do not have any information on magnesium. Okay, so to find the number of moles, we are going to form the ratio of magnesium to that of what? Hydrogen, since they are talking of hydrogen, okay, as the one that was used to produce the hydrogen. Okay, so now here, look at this. From the balanced equation, you look at the number of number in front of hydrogen is a 1, in front of magnesium is a 1. So these have 1-to-1 ratio. What that means that the number of moles of hydrogen is equals to the number of moles of magnesium, and therefore the number of moles of magnesium is equals to as well 0.01 more. Now, have we answered the question at all? So now we go to the formula. This one, finding mass. Mass is equals to number of moles multiplied by molar mass. So in this case, number of moles is 0.01 multiplied by 24, which is the molar mass of magnesium. And this one, what are we going to find? 0.24 gram as the mass of magnesium. So that is the mass of magnesium that produced that volume of hydrogen. Okay, so that is how we answer the question, which means we fully answered that question. Up to the third question, 8.0 gram of impure sodium hydroxide solution reacted with exactly 40 cubic centimeter of 2.0 mole per decimeter cubic or cubic decimeter of sulfuric acid. The first question is, write the balanced chemical equation for the reaction, include state symbols. So please, what I'm urging you here, tomorrow before you write chemistry, make sure that you know this part. And from the playlist that I've made, the playlist, I'll include the playlist, or there's a playlist. If you just go on the playlist, you are going to find a playlist that contain most of the topic that is in chemistry as you prepare. So there's a video that I made on how to write chemical equation. You might want to check out that one before the exams. So sodium hydroxide, let us write the balanced chemical equation. So what is involved there is sodium hydroxide, which is aqueous. We are saying include state symbols, plus sulfuric acid. So all the acids that are used in the laboratory are in aqueous state because they are normally diluted. So what is going to form here is that sodium is going to displace the hydrogen, and you're going to have sodium sulfate plus, this is the neutralization reaction, acid and the base, plus a water. So these are the products that are going to form. This is the liquid, this is aqueous. Then now we are saying balanced one. So how do we balance them? So to balance this equation, we check how many sodium 1, how many sodium 2. So we're going to put a 2 in front of sodium. Sodium 2, sodium 2. But let us look at oxygen. Oxygen here, it is multiplying this 2, okay, which is this one, 2, plus this 4, 6. What about the other side? We only have 5, so we put a 2 in front of water. In front of water, yeah. Hydrogen, we have how many? 4 this side. Hydrogen, we have how many here? We have 2 and also 2 here. So we have 4. Sulfur, we have 1. Sulfur, we have 1. So just by putting the numbers in front of water and in front of sodium hydroxide, we have balanced the equation. So this is the balanced equation with state symbols. Construct a simplified net ionic equation for the reaction. So simplified net ionic equation requires you to split those that are in aqueous. That is the equation that you've constructed. So if you've done the wrong thing when constructing the balance equation, then also this one you're going to get it wrong. So from the balance equation, you split, okay? So you split those that are in aqueous. So from this one, sodium, I'm going to split it. It will be sodium ion plus 2 hydroxide ion. Now, this is where most of you struggle to split as well. So this 2 in front multiplies everything. So which means the ions of sodium hydroxide is sodium ion and the hydroxide ion. Then the acid, when it's split, it is 2 hydrogen ion and not hydrogen 2 like that. No. Then plus that is sulfate ion like that. Then on the other side, you are going to have 2. This 2, it will not be like this. That is most of you that is what most of you do. But instead, the number will come in front. Sodium ion then plus sulfate ion, then of course plus the H2O. In front there's a 2. Okay, in front there's a 2. So this is what I've split. Now what next? What are we going to do next? So we cancel out spectator ions, and those are the ions that are common on both parts of the equation, that is on the reactant and product. So this and that is common. This, do we have sodium ion? No, this one, this and that are common. So what we are remaining with is 2 hydroxide ion plus 2 hydrogen ion, then forming 2 water molecule. So this is the simplified ionic or net ionic equation. I guess there's no one with a problem here. So that is how you simply do it. Okay, let us have a look at the next question, which is B. Calculate the number of moles for sulfuric acid that reacted with 8.0 gram of impure sodium hydroxide. Now, we need to go to the question and look at what information are we given on sulfuric acid. So sulfuric acid, it happens that we are given the volume and the concentration. So therefore, in order for us to find the number of moles of sulfuric acid, we are going to use the formula for concentration multiplied by volume. Concentration is given as 2, so 2.0 that is mole per decimeter cubic multiplied by volume. What is the volume? That is 40. Now 40, we need to convert it in decimeter cubic, and it will be 0.04 decimeter cubic. And I hope you know how to convert. So we just have 2 multiplied by 0.04, which is going to give us 0.08 mole. So this is the number of moles of what? Sulfuric acid that reacted with impure sodium hydroxide. So that is how we find the number of mole. So we've used concentration and the volume that we have. Then the other question now, which is question C. Find the mass of pure sodium hydroxide from impure solution that reacted with 40 cubic centimeter of sulfuric acid. So how do we do this? Okay, so how do we do this? So to find the mass of impure sodium hydroxide, to find the mass of pure sodium hydroxide from impure solution, we need to find the number of moles of what? Of sodium. Okay, so we are going to find the ratio. We use the ratio to sulfuric acid. Okay, the ratio is 2 to 1. So 2 moles, then 1 mole. Okay, then now the one that we found for sulfuric acid is 0.08 mole. Okay, then how much of sodium do we have? Okay, so which means it's just the same as x is equals to 2 multiplied by 0.08. It is going to give us 0.16. So this is the number of moles of the what? The pure sodium hydroxide. Now what we want is to find its mass. How are we going to find its mass? So to find its mass, we are going to use the formula mass is equals to number of moles multiplied by what? Molar mass. Number of moles is 0.16 multiplied by molar mass of sodium hydroxide is 40. So what are you going to find if you multiply 0.16 multiply 40? You should be able to find 6.4 gram. So this is the number, this is the mass of pure sodium hydroxide. Okay, so I can put here mass of sodium hydroxide, which is pure, is equals to 6.4, because we are going to need it at some point. I guess you followed here. So due to space, that is the reason why my work is not that organized, but I hope and pray that you are able to get everything. Then the last question here, that is question D. Determine the percentage purity of sodium hydroxide. So percentage purity, you can say percentage purity is equals to mass of the pure substance, okay, or mass of the pure sodium hydroxide divide mass of the mixture, mass of the mixture, which means impure, multiplied by 100. Okay, then now we have mass of the pure. Mass of the pure we found is 6.4 gram. Then impure, it is 8.0. It is given in the question right here, because some of you might be asking where is it coming from. Then of course 6.4 is the one that we are just from calculating, multiplied by 100, and this is going to give you 80%. So percentage purity is 80% here. Okay, I hope you've gotten a thing. Then now up to the other question. The other question, the first part is define concentration. So what is concentration? So concentration is just the amount of solute dissolved in a unit volume of the solution. So you can say is the amount of solute dissolved, solute dissolved in a unit volume of the solution. Okay, so that is the concentration. So it's the amount of solute dissolved in a unit volume of the solution. Now concentration, the second question is state the SI unit of concentration. So concentration can be in what? Mole per decimeter cubic, or per cubic decimeter, or gram per cubic decimeter. So if they ask you write the SI unit in words, you are going to write in words mole per cubic decimeter. Okay, so these are the, you can either use this or this. You still have that is still concentration, just that this one is called molality. So if you find 2m in front, just know that it's mole per decimeter. Okay, then question 3, calculate the mass of potassium hydroxide KOH that need to be used to prepare 500 cubic centimeter of 0.2 m solution in water. So this m, the whole of it is mole per decimeter cubic. So when you find it, don't get confused what units are behind that. So here they are asking us to calculate the mass. So now what are we going to do? To calculate the mass, you know that the formula is mass is equals to number of moles multiplied by molar mass. The molar mass of potassium hydroxide, we can find it. Okay, we just add whatever is under potassium hydroxide there. But what about the number of moles? The number of moles also we can find. Okay, how do we find the number of moles? So number of moles, we are going to use concentration multiplied by volume, because we have volume and we have concentration. Okay, so here what we have, calculate the number of the mass of potassium hydroxide that need to be used to prepare this and that. Okay, so concentration is 0.25, okay, mole per decimeter cubic, multiplied by what is the volume? The volume, it is 500, but if we are to convert it into decimeter, it will be 500 divide 1000. Okay, divide 1000, what is it giving us? So it's giving 0.5. So multiply 0.5. Then this one multiply 0.25. What is it giving us? 0.15. So 0.125. That is what is giving me as the number of moles of what? Potassium hydroxide. Then now we are going to use this number of moles and find the mass. So mass, we are saying, is number of moles multiplied by molar mass. Now what is the molar mass of potassium hydroxide? So we get the periodic table. What is the atomic mass of potassium? Okay, have we left out any question? No, we haven't. So hydrogen here is 1, oxygen here is 16, then of course potassium is what? Is 39. So if you are to add, that is 17, just more like 17, because 1 plus 16 is 17, plus 39. So it's giving me 56. So here we are going to multiply with 56. And multiply this, what is it going to give us? 1.25. It's giving me 7. So 7 gram. That is what it is giving me as mass of potassium hydroxide. So please, mistakes can be made when calculating and the procedure. So as you go through, make sure that you verify the answers. Okay, otherwise that is how we can answer the question. Then B, construct a balanced chemical equation, net ionic equation for the reaction between potassium hydroxide and sulfuric acid. So let us start with a balanced chemical equation. So potassium hydroxide, which is aqueous, react with sulfuric acid, which is aqueous. Then this results into formation of potassium sulfate as a salt, which is aqueous, plus this is an acid and a base, water is formed, which is a liquid. Now if you have to look at this, potassium 1, potassium 2, so we put a 2 here. Potassium 2, oxygen 2 plus this 6. Oxygen the other side, we have 2. So we put a 2 there, it will be, if we put a 2 there, it will be oxygen, this 2, it will be 2 plus that 4, 6. Then hydrogen 4, hydrogen this side, this 2, and this one, it will be 4. Then sulfur 1, sulfur 1. Okay. Then the equation is balanced. So that is a balanced equation. Now, net ionic equation, we said we split the aqueous from the balanced. And I said if you don't balance it, then it will be very difficult. So we start splitting. So it is going to be, let me just write it, copy it the way it is. Then aqueous plus, that is sulfuric acid, which is aqueous. Then to form potassium sulfate, which is aqueous. Then plus 2 water molecules. So this one I'm going to split it. So it's going to be 2 potassium ion plus 2 hydroxide ion. Then plus this is going to split to be 2 hydrogen ion plus sulfate ion. Then here the other side will only have potassium sulfate in aqueous. So it will be 2 potassium sulfate plus, potassium ion plus 2 sulfate. Then plus 2 water, 1 sulfate plus 2 water molecule. So now you cancel out spectator ions. So what is common? Potassium, we have potassium. We have sulfate, we have sulfate. And what remains? 2 hydrogen ion plus 2, that is hydroxide ion plus 2 hydrogen ion. What remains there is 2 water molecule. So that is the and this is liquid, this is aqueous, this is aqueous. Okay, so that is what we needed to write here. Okay, then now we go to this other question. So 2.0 gram of pure magnesium ribbon reacted with exactly 100 cubic centimeter of 2.0 mole per decimeter cubic of hydrochloric acid. Construct a balanced chemical equation. So you've seen most cases construct a balanced chemical equation is a question. So how are we going to do it? So to construct a balanced chemical equation, we are talking of magnesium. So others will get confused. Magnesium ribbon. Magnesium ribbon, magnesium is just one and the same. So we have magnesium, which is solid, reacting with hydrochloric acid, HCl, which is aqueous. Then now to form what? A salt, which is magnesium chloride, which is aqueous. Then hydrogen gas, because it's an acid and a metal that is reacting, which is a gas. Is this balanced? Magnesium 1, magnesium 1, chlorine 1, chlorine 2. So I put a 2 here, which means hydrogen 2, chlorine 2, magnesium 1, magnesium 1. So this is the balanced equation. Okay. Determine the limiting reagent. Now, what is the limiting reagent? That is the question you should ask yourself. So the limiting reagent is just a reactant that is in short supply. And to find the limiting reagent, you just have to follow 2 steps. The first thing, you find the number of moles of the reactant. You deal with the reactants. So reactant are substances that are reacting. So you find their number of moles. Then after you are done, you divide the number of moles that you found by the coefficient in front. In the case of number of moles of acid, we are going to divide the 2. But for magnesium, we are going to divide the 1. There's a 1 in front here. Then the one with the lower number of moles is a limiting reagent. So let us do that. Now, which one are we going to use to find number of moles? Look at the information that we are given on magnesium first. We are given the mass. So which means to find number of moles, we are going to use number of moles of magnesium equal to the given mass over molar mass. What is the given mass? 2.0 gram. What is the molar mass of magnesium? Is 24 gram per mole. So gram and gram will cancel. Then 2.0 divide 24 to give us 0.083. So be able to confirm these numbers as you go through more. Then like we said, we divide with a 1. We are still going to find 0.083 more. Then we can find the number of moles of HCl. Now on HCl, we are given the volume, as you can see, and the concentration. So number of moles is equals to concentration multiply volume. Volume is supposed to be in decimeter cubic, so you divide this one by 1,000. So you are going to multiply a 2 multiplied by converting 100 into decimeter to give us a 0.1. And this should be able to give us a 0.2 mole of what? Of hydrochloric acid. But in front of hydrochloric acid, there's a 2, so divide 2. So it's going to be 0.1 mole. Then you compare these. Which one is less? 0.083 and 0.1. You find that the one that is less is this one. And therefore, we can conclude that magnesium is the limiting reagent. So don't just calculate. At the end, you need to state the limiting reagent after you've shown the calculations. Okay? Then calculate the volume of the gas evolved. So now when you are calculating the volume of the gas, you are dealing with a reactant when you find the limiting reagent. But when you are calculating the volume of the gas, which one do you form the ratio with? Hydrogen, are you going to form it with hydrochloric acid or with magnesium? It happened that you pick the limiting reagent. So you are going to have magnesium to hydrogen. Now if you are to look at this, in front there's a 1, in front there's a 1. So calculating the volume of the gas evolved, which is hydrogen, volume, you remember this formula, mass, number of moles is equals to volume over molar gas volume. Which means if you want to find the volume, which is this one, you're going to have volume is equals to number of moles multiplied by Vm. So which means you need to find the number of moles of hydrogen. So the way you find the number of moles of hydrogen, you form a ratio. Since these are 1-to-1 ratio, number of moles of hydrogen is equals to 0. You get the original one, 0.83 mole. Then it's the one that you are going to multiply with Vm. Now Vm, we are told that is at RTP. And therefore you say 0.083 multiplied by 24. And in this one, you are going to find 1.999992 gram as the volume of hydrogen. Okay, so that is how you know. Why am I putting gram for volume? So it will be, let me just bring it here, 1.992 decimeter cubic. That is the volume. Okay. Alright, let us have a look at this question. In the experiment to prepare a salt, Elena reacted 3.0 gram of magnesium oxide with 40 cubic centimeter of dilute nitric acid. Okay, and nitric acid of the concentration is given 2.0 more decimeter cubic. Write the balanced chemical equation for this reaction. So in all the cases you've seen, you need to know how to write the balanced chemical equation. So here you have magnesium oxide. Magnesium oxide is written as MgO, which is a solid. Reacting with nitric acid is NH3, that is HNO3, which is aqueous. This is going to form magnesium nitrate as a salt. And I urge you to know the radicals and their valences. So this is a base, so we are going to form water, which is a liquid. Now, is this equation balanced? No. So we put a 2 in front of nitric acid, and the equation is balanced. So we have magnesium 1, magnesium 1. Hydrogen here, hydrogen how many? 2, hydrogen 2. Oxygen, we have 2 multiplied by 3, which is 6 plus 1, 7. Then here 2 multiplied by 3, 6 plus 1, which is 7. So this is the balance equation. Calculate the number of moles of magnesium. So you take note of what you are given on magnesium. You are given the mass, which is 3.0. So number of moles of magnesium oxide is equals to given mass over molar mass. This is going to be 3.0 gram divided 24 gram per mole. And what is it going to give you? This, if you divide it, to give you 0.075 mole. Be able to confirm this one. So 0.075 mole as the number of moles of what? Magnesium oxide. Then the number of moles of dilute nitric acid. Now, what are you given on nitric acid? You are given the volume and the concentration. So number of moles of nitric acid, is equals to concentration multiplied volume. So the concentration is 2.0 more decimeter cubic multiplied by the volume is 40. We just divide this one by 1000. What are we going to have? 0.04. Okay, 0.04 decimeter cubic. Decimeter cancel. So 2.0 multiplied by 4 is just the same as this one. Should be able to give us 0.08 mole. Okay, that is the number of moles of nitric acid. Okay, then determine the limiting reagent. So to determine the limiting reagent, the number of moles that we've gotten, since the reactant is magnesium oxide and nitric acid, you just look at the number of moles. From the balance equation, in front of magnesium there's a 1, in front of nitric acid there's a 2. So what do? We divide this one by 2 and it's going to give us 0.04. Then we divide, which one? The number of moles of nitric acid, magnesium oxide by 1, which is just going to give us the same one. So which one has the lower number of moles? Is it nitric acid or magnesium? So you are comparing 0.075 and 0.04. It happens that this one has the lower number of moles. So therefore you can write nitric acid is the limiting reagent. So these you can never tell just by looking. You need to work them out. So it's a limiting reagent. Then let us have a look at this question. Excess of zinc metal was added to 200 cubic centimeter of 2 morality, that is hydrochloric acid, or 2 more per decimeter cubic. Like I said, this M is more per decimeter cubic. It's concentration. Write the balanced chemical equation. So we have zinc reacting with the hydrochloric acid. So zinc, which is a solid metal, reacting with HCl, which is aqueous. Zinc has a valence of 2, so it will be zinc it will be zinc chloride, which is like this, then plus hydrogen gas. Okay, so how do we calculate the number of moles of hydrochloric acid produced in the reaction? So for the number of moles of hydrochloric acid, we look at the information that we are given. The information that we are given the molality of hydrochloric acid. So we are going to use the concentration. So number of moles of HCl is equals to concentration multiplied by volume. So the concentration is 2 mole per decimeter cubic multiplied by, that is 200. I'll divide 1000, okay, as we are converting. So this one is going to give me a 0.2, so it will be 200 divide 1000, which is 0.2. So 0.2 multiplied by 2, it is going to give me 0.4. So 0.4 moles. That is the number of moles of hydrochloric acid. Then the volume of the gas evolved at RTP. How do we find the volume of a gas evolved at RTP? Now here we are told excess of zinc, which means the limiting is what? Hydrochloric acid. So we are going to form a ratio of hydrochloric acid to the gas, which is hydrogen gas. Now these are 1-to-1 ratio, which means the number of moles of hydrochloric acid is equals to the number of moles of what? The gas. Okay, so hydrogen, number of moles of hydrogen, therefore, is equals to 0.4 moles. Okay. Then now, we need to find the volume. So to find the volume, we use the formula volume is equals to number of moles multiplied by Vm. This is at RTP. So we multiply 0.4 multiplied by 24. So this time around, please expect also, you need to know also the STP, because most cases we find RTP. So don't get used to this one. So 24 multiplied 0.4, it is giving me, that is 24 multiply 0.4. This one is giving me 9.6, so decimeter cubic. I guess we've done the right procedure. Okay. Volume of the hydrogen gas produced at STP. All right. So 9.6. What mass was used in the reaction? What mass of, I don't know what this one, of zinc, should be of zinc, was used in the reaction, or what mass of zinc was used in the reaction? Anyway, whatever the question is we are unable to calculate it because of the incomplete. So I've put what mass of zinc was used in the reaction. So can you calculate that one to see if it will give you something? Then the other question that we can answer here, it is this question. The question is define a mole. Define a mole. So what is a mole? What is a mole? So a mole is just an amount of substance that contain, so we can say is the, amount of substance, that contain as many elementary particles, as they are atoms in exactly 12 grams of carbon 12 isotope. So that is how you define a mole. Then the concentration of sodium hydroxide solution is 0.25 mole per decimeter. Calculate the number of moles of 0.25 mole per decimeter of sodium hydroxide solution contained in 250 centimeter or cubic centimeter of the solution. So now we are calculating number of moles of sodium hydroxide. So number of moles is equals to, that is number of moles of sodium hydroxide is equals to concentration multiplied by volume. The concentration is 0.25 mole decimeter cubic, which is equals to multiplied by the volume is 250 divide 1000, okay, decimeter cubic divide 1000, which is going to give us 0.5 as well. So we are multiplying 0.5 multiply 0.5. I mean 0.25 multiply 0.25. And what is it giving us? 0.0625 mole. So this is the number of moles of sodium hydroxide. Okay. Then iron metal is extracted from an iron ore called hematite in a blast furnace during the reduction reaction using the carbon monoxide gas as a reducing agent as shown. Okay, as you can see from here with a balanced equation. Calculate the mass of carbon monoxide gas required to reduce 3,200 kg of iron to iron 3 oxide in the blast furnace. Okay, so from this reaction we are saying calculate the mass of carbon monoxide. So we have carbon monoxide and the iron 3. So we are going to form the ratio of iron 3 and the carbon monoxide. Is it carbon monoxide? Where is it? This one. So iron 3 to 3 carbon monoxide. So here we are going to use mass to mass. Mass to mass, we find the molar relative molar mass, then we treat as mass using the units that are given of mass. So we are given in kg. So what is the relative formula mass of iron? If you add everything, you are going to find 160 kg. In this case, what about carbon monoxide? Carbon monoxide, you are going to find 40. That is 16 plus 12, but multiply 3, which is 84 kg. Then what about 3,200 kg of iron? What would be carbon monoxide used? So if you cross multiply here, you are going to have 160 kg. You are going to have 160 kg x is equals to 84 kg multiplied by 3,200 kg divide 160 kg. Okay, so here we can cancel that. We can cancel 1 0 here. So which means we have 84 divide 320. 84 multiply 320 divide 16. I should be able to find 1,880 kg. Okay, so this all information should fit in this box, please. So that is how we work it out. Then let us have a look at this question. Calcium nitrate decomposes on heating according to the equation. Copy the equation and give the balance and balance it. So you're copying the equation and balancing it. Okay. So to balance this one, we just put a 2 in front of calcium, then nitrate. I guess there's no one with a problem on how to balance the equation. Then of course a 2 calcium oxide, then plus 4 nitrogen dioxide plus oxygen, something like that. So please, this is the balance equation. Be able to check it out if it's balancing. Then calculate the relative formula mass of calcium nitrate. Calcium nitrate, what is the relative formula mass of calcium nitrate? So calcium nitrate, the relative formula mass, you just look at it. For calcium, what is calcium? 40. Then here you have nitrogen, which is 12, but there are 2 multiplied by 2. Then oxygen, this is 6. So oxygen is equals to 6 multiplied by 16. Okay. So now 6 multiplied by 16 is 96. Then this is the 20. Nitrogen is 14, please. I forgot. So this is 28. Then this on top here, that is calcium, which is 40. So if you were to add these, you should be able to find 166 okay, as a relative formula mass. So confirm these numbers. Then 16.0 gram of calcium nitrate is composed. Calculate the volume of a gas liberated at room temperature and pressure. So how do we calculate the volume of a gas? The volume of a gas produced is the oxygen. So here is oxygen, please, is O. So the gas that is liberated is oxygen. Now they are saying calcium nitrate is decomposed. So which means for us to find the volume of a gas, we need number of moles, then and its Vm. We are told at RTP, so the Vm is sorted out, which is 24 decimeter cubic per mole. Then number of moles, we don't know the number of moles of the gas. So for us to find the number of moles of a gas, we are going to form a ratio of calcium nitrate to oxygen, because the gas that is produced. Okay, the gas decomposed, calculate the volume of a gas, oxygen. Okay, so that is the ratio that we are going to form. Now this is the 2 to 1 ratio. So 2 moles of calcium nitrate decomposed to produce 1 mole of oxygen. Now we are looking for the number of moles of oxygen for us to calculate the volume. So which means we need to know the number of moles of nitrate in this 16.0. I mean 16.4. So we are going to find the number of moles in 16.4, which is given mass divide molar mass. Given mass is 16.4 gram. Molar mass of calcium nitrate, we found it, which is 166 gram per mole. And if you divide there, what are you able to find? If you dividing that, I'm able to find 0.099 mole. Okay, so that is the number of moles. So 0.099 mole. What will be of oxygen? Then we cross multiply. So it's just the same as x is equals to 0.099 divided 2 mole. And what are you going to find? You're going to find 0.0495 mole. So that is the number of moles of oxygen. Then we can now calculate the volume of oxygen. Okay, so volume of oxygen is called 0.0495 multiplied by 24. And if you multiply this, should be able to find 1.188 decimeter cubic as the volume. Okay, so that is how you simply work this one out. Then let us have a look at this question. In an experiment, to find the concentration of the solution sodium hydroxide, 0.1 mole of hydrochloric acid was run from the bullet into the conical flask containing 25 centimeter or cubic centimeter of aqueous sodium hydroxide until neutralization took place. 20 cubic centimeter of the acid was required. Name the suitable indicator for this reaction. So this has been a long time. Okay, and by the way, this one more like came in 2023 or 2022. So it is on a acid base reaction on titration. So you need to know this part. So name the suitable indicator to use in this experiment. So the suitable indicator to use is phenolphthalein. And of course you should be able to know why. Let me just write it nicely. Phenolphthalein, something like this. Okay, describe the color change when that would be observed when neutralization occurred for the indicator you have named. So we are saying the suitable indicator is phenolphthalein. That is according to me. So if you have another indicator that you can use, be able to tell. Now phenolphthalein is an indicator. In acid, it turns what? Colorless. Then in the base, it turns what? Pink. Okay? It turns pink. So now describe the color change that would be observed when the neutralization occurred. Now, when you are doing titration, you put the indicator in the acid and then you open the bullet where there's a base. It is running into the solution. So when all the acid are neutralized, the indicator turns pink, which means you have some presence of the base. I guess you understand that. Okay, so describe the color change. Okay, so the solution will turn pink. Okay, from colorless it will turn what? Pink. Write down the chemical equation for the reaction that take place in the conical flask. Now in the conical flask, if you look at this, what is reacting is sodium hydroxide and hydrochloric acid. So you're going to have sodium hydroxide, which is aqueous, reacting with hydrochloric acid, which is aqueous. This is the base acid reaction, which is forming a salt, sodium chloride, which is aqueous, then plus water. Okay, is this balanced? Sodium 1, sodium 1, oxygen 1, oxygen 1, hydrogen 2, hydrogen 2. So this is the balanced equation. How many moles of hydrochloric acid were used in the experiment? So number of moles of hydrochloric acid, which formula are we going to use? We are given from the hydrochloric acid, we are given its concentration, and they are saying 0.1 of hydrochloric acid was run from the bullet into the conical flask containing 25 cubic centimeter of aqueous solution. Hydrochloric was run from the bullet. Okay, so please let me just make a correction here. Here we are told it is not the acid that was in the conical flask. Instead, it was a base. So when you put the conical flask, when you add the indicator, which is phenolphthalein, the solution will turn what? Pink. Okay, will turn pink. Then when you run the acid and you reach the end point, it will turn colorless. So it is the opposite. Okay, so the solution turned colorless. Okay, just make a correction on this one. Then we are told now calculate the number of moles. So number of moles is equals to concentration multiply volume. What is the concentration of the acid? Is 1. Then they are saying run from the conical flask sodium hydroxide until neutralization took place. 20 centimeter cubic of the acid was used, so which means the volume was 20 and not 25. So we have concentration, which is 0.1 multiplied by 20 in decimeter cubic is just the same as 0.02. If you multiply this, you're going to find 0.002, okay, mole. So that is the number of moles. I guess you've gotten that. Using the equation in B, calculate the number of moles of sodium hydroxide. Using the equation in B, calculate the number of sodium hydroxide. So if you have the number of moles of acid, which is 0.002 mole, calculating the number of moles of sodium hydroxide, because here you can form a ratio of sodium hydroxide to hydrochloric acid. Now sodium hydroxide is 1, also this is 1. Okay, that is the reason why this question was 1 mark, because it's a 1-to-1 ratio. Therefore the number of moles of sodium hydroxide is equals to the number of moles of hydrochloric acid, which is 0.002 mole. Calculate the concentration of the sodium hydroxide in the in mole per decimeter cubic. So how are we going to calculate the concentration? Okay, so you are going to use the dilution law. I guess you know this. The first concentration, that is of the acid, was 0.1. Okay, so we have 0.1 multiplied by the volume was 20, which is 0.02, equal to Then the concentration of the base we do not know, which is second, the concentration, the M2. Its volume we know it was 25 in the conical flask. 25. If you were to convert it into decimeter, 25 divide 1000 is what? 25 divide 1000 is equals to 0.025. 0.025. Then we find the answer now. This side we found it at 0.002. Okay, so 0.002 equal to M2 0.025. So we divide 0.025 divides 0.025. M2 or concentration 2. What is the concentration 2? So 0.002 divide 0.025. I'm able to find 0.08 mole per decimeter cubic. That is how you find the concentration. So you use this, what you call dilution law. Okay. Give the reason why the bullet was used to determine the volume of the acid, not the measuring cylinder. How was the exactly 25 cubic centimeter of the sodium hydroxide transferred into the conical flask? So using a pipette. Now a pipette measures the fixed. Is it the fixed? The accurate. This one we are supposed to, okay, measures the fixed volume of the acid. Now this one I was supposed to put not fixed but accurate. Accurate. Okay. So it measures the accurate volume of the substance, that is the acid, but this one measures the fixed. Fixed, which means 25 centimeter, it holds the volume of 25 centimeter, not above that. That is what it means, fixed. Okay. Otherwise, we've come to the end of the presentation, and please, if you've not registered yet for online lessons, that is for GCE next year, you can WhatsApp the number 0976 402563. Otherwise, see you in the next one, and all the best.